Hello, welcome to the GATE 2021 CE Set 2 question number 2, in which we need to find the rank of a matrix. The basics of this topic is given in NPTEL course Engineering Mathematics Matrix Algebra Part 3 by Dr. P.N. Agarwal of IIT Roorkee. So before solving the question, let's have a basic understanding of rank of matrix. So what does rank of matrix actually mean? It is the number of linearly independent rows or columns in the matrix. What does it mean? If we take a matrix A in which the elements having Aij with m number of rows and n number of columns, then rank of A will be is equals to number of non-zero rows if we are doing the row operations, or non-zero columns if we are doing the column operations for a square matrix which have rows and columns equal. For having different number of rows and columns, the rank will be less than equals to minimum of m and n, that is rows and columns. So in the definition, as the name suggests, linearly independent rows, it is nothing but the number of rows that cannot be made zero using the row operations. Okay, let us just quickly see some of the properties of rank of matrix. So a matrix will be having a rank of 0 if and only if the matrix itself is 0. So here matrix A is 0 matrix. Other property we already saw for non-square matrix, right, in which let's say this is a 3 by 4 matrix. So by this definition, rank of matrix will be definitely less than equals to 3. Also, if a matrix is non-singular, that determinant of A is not equals to 0, then this condition only occurs when there are no linearly dependencies between number of rows or columns. Since there is no dependency, the rank of matrix will be is equals to n if the matrix A is square matrix, and if it is singular, then definitely there will be linearly dependencies, then only the determinant can be made 0. So here rank of A for a square matrix will be definitely less than n. Note, here it is not less than equals to. Why less than n? Because there is at least one row or column which is dependent to other row. That's why it's singular, right? Now without wasting our time, let us just directly jump into the solution. So in order to find the rank of the matrix, we will try to make the rows or columns fully 0. Okay, and the number of non-zeros rows or columns will give us the answer. So in this question we will use the row operations. You can use also the column operations as per your choice. So here we can see that row 1 and row 3 are equal, so they are linearly dependent. To make one row 0, we'll use the operation R3 such that R3 minus R1. This will give us the new matrix, that is 5 0 minus 5 0 0 2 0 1 0 0 0 0, because R3 made 0 using this operation, and 0 1 0 2. So this is our first set of operation and we got our new matrix. Now again we will try to see the linear dependency between these rows, that whether any of these rows can be made 0 using the other row or not, using the row operations. So as we can see clearly here that no other rows can be made 0. For the simplicity purpose, we can replace row 3 with row 4. So our matrix will look like this. So there are 3 rows that cannot be made 0, means they are linearly independent, and thus this gives the rank of the matrix A is equals to 3, and thus the final answer to our question is C. So in simple words we can say the rank of the matrix is the number of rows which cannot be made 0 or the number of columns if we are doing the column operation, which cannot be made 0. Okay, that solves our question. Thank you and keep learning.